Hi, thanks for stopping by. This is Tinkerneering with that Rob Clark. I've been upgrading this laser engraver to make it easier to get repeatable results. Let me show you how. Before we get started, I just want to say I am going to be taking the case off of this. So, rule number 1 applies. Don't take something apart unless you have a plan to put it back together again. But as with all projects, make sure you read and understand all of the instructions that come with your tools. Turn off and disconnect any power supplies before starting. And, since we're working with lasers, there's nothing more important than these. Safety glasses. Now, let's get on. This is my laser engraver. Objects to be engraved are clipped or strapped to this shiny metal plate, and a 2-watt laser shines down from above. Since it's made from cheap parts, it's cheap to buy. It's also pretty easy to take apart and put back together again. First, separate the base plate. There's just a little bit of glue holding it in place. This frees up the mechanism inside. Now loosen and remove the 4 screws around the base. Now you can lift up the black plate covering the drive mechanism. See what I said earlier about cheap parts? Each axis is made from the same parts used in a DVD drive. Next, we undo the nuts that are holding the drive in place. Once they're out, we can lift up the whole assembly and undo the screw that's holding the bracket in place. If you can't get the silver base plate off, you can do this all in one go. Just be patient, it's a bit fiddly. Now, I don't know about you, but I don't think that using a mirrored surface is a great idea for a base plate when you're working with lasers. What I need now is a replacement for this bracket. My go-to material when I'm building things is usually HIPS, plasticard. I can snap it to the sizes I need and then stick it together with some polystyrene cement. That's the same stuff you use to build model planes. I got to this point and I wondered if anybody else had had a go at doing this. And as luck would have it, I found a fantastic Instructable by Professor Hank Dietz of the University of Kentucky. All his parts are available on Thingiverse, including a brilliantly designed replacement for the base. I did all this back before we had a 3D printer in the Tinkerspace. So that's why I turned to 3D Hubs to get my 3D printed part. 3D Hubs is a manufacturing broker and it works like this. You upload your designs, you tell them how you want it to be made, and then the parts are made by a local creator. First I told 3D Hubs that I wanted something to be printed. Then I uploaded the base part as an STL file. I told them what kind of material I wanted it to be made in. Then at that point I could have just let 3D Hubs decide where to have it made and get it posted to me. But you can pick from a preferred maker, and I picked these guys, Spannerhands and Cavilli. The advantage being that I can pop over to their workshop and pick up the parts myself. And this is the high quality part I got back, printed on one of their Prusa i3 3D printers. The design of the model and the quality of the print meant that I could fit it straight away, reusing the screw that I'd taken out earlier. The premise here is that you use different jigs in conjunction with the base, depending on what you're trying to engrave. This model leaves room for a thin layer of magnetic tape, so I cut that down to size and created a magnetic base, allowing me to quickly swap different engraving platforms. I found it best to line up extra pieces of tape with the base and then fit the jig to the tape. The problem I had was that the jig that came with the rest of the design wasn't the right size for the blanks I bought from the hobby store, and to reprint the entire jig for each different size blank seemed to be a waste of plastic. So I rough printed a raised platform, onto which I could then snap on these smaller jigs of my own design. Here's how it works. Magnet first, then the base, then the snap-on frame, and then the piece to engrave. This worked really well as a first attempt, but it was lacking one feature. I couldn't guarantee that the centre point of the X and Y axes was in the middle of the disc to give me the maximum engraving area. So I went away and redesigned the jig into 3 parts. The first piece fits over the base plate like this. The second piece can slide along the first, allowing translation in one of the axes. The third piece can then slide along the second, allowing translation in the other axis. And then the frame specific to your piece snaps in over the top. And now I can swap my frame to a different size in a matter of seconds for different size blanks, and have the confidence that everything will be in the right place. I'm doing this with the laser on very low power just to illustrate the process. And with the jig in place, I'm ready to engrave. Next, I wanted a quick way to screen off the sides of the engraver. This would help prevent the laser light leaking into the room. I had some black foam core lying around, so with some more of that magnetic tape, I made 4 walls that would stick to the outside. Now I can run off coins of different sizes at a moment's notice. And I've also been able to make these keyring fobs. In fact, I dropped a few of these on the YouTubers table at Maker Central this year, so if you were able to pick one up, well done. I have a few left, so if you want to send me a message explaining why I should send you one, I'll pop one in the post of the top 5 answers I receive. I can be contacted on all the social medias, just follow the links in the description below. If you like this video, please leave me a message in the comments, and don't forget to subscribe. That's it for this time. I'll see you again soon.